Okay, so mensuration, I've never seen it written like that, so I'm guessing, and P2, are you doing IGCSE? What type of GCSE are you doing? Just so I can get a good idea of the syllabus of what that would be for, because I'm obviously, when I do the normal GCSE, I've not seen it named like that, and I've not seen it have a topic called P2, if that makes sense, like a section. So let me know what type of GCSE, IGCSE. Oh, is that the Cambridge one? I think that number seems to be the Cambridge one. Cambridge. Yeah. Oh, P2 is paper 2. Okay, gotcha. All right, yeah, so IGCSE is the international one, isn't it? Okay, we can have a look at the syllabus and it should tell us then. So I'll just see if I can find the syllabus. And I'll search for that. Right, yeah, topic number 5 it says. I can bring this over here. I've just like literally Googled the syllabus for, as you said, Cambridge IGCSE 0580. And then here's your topic number 5. So they've said units of measurement, obviously here, metric units specifically, so you can see the examples, millimeters, centimeters, meters, kilometers, but also the cubed versions and some of the squared versions, milliliters, liters, grams, kilos, area and perimeter, so rectangle, triangle, parallelogram, and trapezium. Except for area of a triangle, formulas are not given, so I guess you'll have to know all of the rest of those. They've got obviously circles, arcs, which is, you know, like a small part of the circumference, and sectors is like a small part of a circle, isn't it? You might give them in terms of pi. I guess if that's a non-calculator paper, they won't make you work it out. Yeah, so for non-calculator, I would suggest, this is a bit here, you could do circles and stuff, but they won't necessarily make you calculate pi if it's a non-calculator paper. I've seen this with Edexcel, they normally just say, give your answer in terms of pi, so you might not need to calculate pi as such in your non-calculator one. Obviously surface area and volume, again, they might get you to do it in pi if it's a cylinder, cone or something, a sphere. Now here's a list of the formulas they do give you though, so it'd probably be quite good for you to know which ones you don't need to memorize. I'm sure if you Google it, if you just put in Cambridge IGCSE maths formula sheet, I'm sure it will come up, so you can see which ones you don't need. And then compound shapes, so that's just where, you know, when you've got two shapes stuck together, so maybe it's like an L shape, and you just have to break it back up into the different shapes that you can recognize. Obviously, in terms of non-calculator, any of the shapes could come up. I don't know how they would split that, because again, with like Edexcel, for example, it's just throughout all 3 papers. Let's see, what else does it say it? We've just said that one, haven't we? We've said that one. Oh, that's it. Yeah, that seems to be the list, I guess, on the syllabus. I don't teach IGCSE Cambridge, so I don't know it personally like that well, but just from looking at the syllabus, I don't know if that answers your question. And then you said about the root. I know with Edexcel AQA, which I know is not IGCSE, but just to give you a comparison, they won't make you square root anything that's not a square number already. You might have surd, you know, surds where you have to simplify it. You simplify the surd, but you don't actually have to square root. I don't know if that's the same for Cambridge, but for the other ones, I know that they haven't made you square root anything that is not already a square number, or cube something that's not already cube root something that's not a cube number, for example. So I'm assuming it's probably the same, because I wouldn't even know how to do that. I've never learned how to do that myself, so I don't know if that's the same for Cambridge. Yeah. Okay, Maury said, what topics would you prioritize and revise if you were doing last minute revision? So obviously Edexcel, the first one in 2 weeks today, is your non-calculator. So I can give you, I have a couple of videos coming out. They're not out this week. I think it's next week. that is kind of like that, like the most common topics for non-calculator, and then obviously in a few weeks I'll do the same for the calculator, and it's for Edexcel specifically. So I can give you the list of the topics that I will be going through if you want to look at them ahead of time. I went through all the past papers, all the non-calculator past papers for Edexcel, and I had a look at which topics came up the most. So let me grab my list really quick. Most common. I mean, it's quite a big list, but then I've got kind of one that would be last minute. I've made like a 13-minute video, which will upload on the day as well. Let's see if I can copy and paste this. Yeah. See if it's going to paste it. Yeah. This is the list that I made a video for non-calculator where I said most common topics. Or most repeated topics. This is what I would suggest. Decimal calculations, what I mean by that is multiplying and dividing, right? Obviously adding and subtracting is pretty straightforward, but they ask quite a lot about multiplying and dividing. Fractions operations, so that's all of them. Multiply, divide, add, subtract, but actually this one is quite commonly they use mixed numbers. So you know improper fractions and mixed numbers. So you need to know those as well as adding, subtracting, multiplying, dividing. Highest common factor, lowest common multiple, and also product of prime factors. You know when you have to do the factor tree like this, you do that and then break it down into factors. That comes up a lot. Obviously that could also come up on calculator. It just depends on the year, but it does come up quite a lot. I've seen a few times, obviously percentages, you need to just make sure you know how to do percentages without a calculator, but reverse percentages, I don't know if you know what I mean by that, but you know, for example, if they say something has been reduced in the sale by 20%, it now costs this much. How much did it cost originally? That's like a reverse, isn't it? So that kind of scenario. Cumulative frequency and box plots. Cumulative frequency is more common than box plots. I would suggest you probably get one or the other. Yeah, percentage change, as you said. Percentage profit as well is basically the same thing as percentage change, just with the context. That can come up quite a lot. Yeah, cumulative frequency comes up a lot in non-calculator. Again, none of this is kind of guaranteed, but it's just suggestions, right? Box plots possibly could come up instead of cumulative frequency. Sometimes they come up in the same question if you want to, they ask you to convert from a frequency graph, a cumulative frequency graph, into a box plot maybe. Index laws obviously comes up a lot. Negative and fractional indices also come up a lot because obviously they don't want you to work it out with your calculator. Algebraic proof seems to come up, not like loads, but it seems to come up a lot in the non-calculator. Area with algebra, so you know when it's just like different area questions and they kind of label the sides of a rectangle with X or something. Volume of cones and spheres, that surprisingly comes up quite a lot, even though it's non-calculator, but as I said in the other question, obviously they're not going to ask you to calculate pi. They'll just say, give your answer in terms of pi. Or the worst case scenario will be, you know, with estimation, they might say estimate your answer, in which case you have to take pi as equal to 3. So that's pretty straightforward. Obviously recurring decimals to fractions, that could come up in any of the exams really, but I feel like it leans a bit more towards non-calculator. Proportion seems to come up quite a lot. Again, it could come up in any of them though, couldn't it? Function, so this is kind of in a rough order of, like roughly in order of difficulty, I would say, this list. So obviously functions tend to be towards the end, don't they? Sometimes they're only a couple of marks each, but it's like part A, part B, part C, so it adds up to a lot. Or sometimes it might even be a 4 or 5 mark question, so functions might be a good one to look at. Solving simultaneous equations graphically, that one's quite easy actually. That's like 2 marks. And then surds. Surds can be quite a high mark question. 3 marks onwards, I would suggest. 3 to 5 marks. So maybe have a look at rationalizing denominators of surds. Again, because that's one they want you to work out without a calculator, isn't it? That was my kind of general list. I think high mark, it's quite hard because obviously this is for non-calculator, but generally the higher mark questions, maybe even you know, solving quadratic inequalities, but that could come up in any of the papers. So it wasn't kind of common enough for me to write it for non-calculator specifically, but obviously it still could come up. High mark questions is normally a lot of shape questions, probability sometimes, you know, when you've got to make a really big probability tree, that can be 5 marks sometimes. Circle theorems can come up on any of them. Yeah, it's not specifically paper 2 or paper 3, I don't think. I would suggest it could come up on any of them. I haven't written it down because I guess it didn't come up paper 1 loads, so I didn't write it down that it came up loads, if that makes sense. So maybe it's more likely a paper 2, paper 3, but technically it could come up. You don't need a calculator to work them out, you know, so it could come up on any of them. Okay. Let's see. Yeah, I think ultimately, I mean, GCSE maths, GCSE maths are all kind of very similar. It's still maths ultimately, isn't it? You just might have a few extra things than us, or some things that you don't have. O-level. I'd have to look that up. I mean, O-level is what my dad used to call it, so I don't know if that's what they used to call them, but then I don't know if it's like nowadays. Let's see, O-level, Cambridge maths, let's see. Just searching it. Yeah, it says, if you just Google it, it says yes, Cambridge, I don't know if you're talking about Cambridge as well, it comes up with Cambridge O-level in maths is generally considered equivalent to a UK GCSE in maths. So I think so. Okay, what else have we got? Would volume of cones and sphere come... Okay, so the volume of... Right, so anything that's not a prism, so obviously a cone is not a prism, a sphere is not a prism, and sometimes pyramids, but generally not too often. Obviously that's not a prism. Those they will give you the formulas for, and they will give it to you in the actual question. It won't be on the formula sheet, it'll be in the question. So that would apply for, obviously, as you said, volume. And surface area of a sphere will be given to you, because again, that's kind of complicated. And surface area, not of the whole cone, but of just the curved bit of the cone. So like the kind of bit around the outside. That's the thing. So surface area of a cone, you would have to remember yourself to add the other circle, you know, the base of the cone. You'd have to add that yourself. So they'll give you just the curved area of the cone. A pyramid, they won't give you the surface area because obviously it's just made up of literally triangles and squares, rectangles, so you could figure that out. Well, not necessarily. It's just the surface area of the cone, you don't necessarily have to remember it as a whole if you don't want to remember it as a whole. They will give you part of it, but you have to just remember to add, because you know surface area, you add all the sides together. And if you think about a cone, it has 2 sides. It has the circle at the base, and then it has the curved kind of cone bit, right? They give you the cone bit formula, but you'd have to remember to add the circle. Now, actually, because this year is still the COVID one, the COVID formula sheet, so you actually do get pi r squared, you know, the area of a circle. You do actually get that on your actual formula sheet, on your formula sheet as well. So you just have to remember to put 2 and 2 together. The other thing I've seen a lot with Edexcel, and sometimes with AQA, is you get a lot of hemispheres, you know, half of a sphere, but they will give you the formula for a whole sphere. So you have to remember to like half it if it's the volume, and if it's the surface area, you need to remember that obviously a hemisphere, similar to a cone, has 2 sides. It has obviously the kind of half sphere bit, and then it has the circle. You'd have to remember to add the circle, because again, they won't add it for you in the formula. Let me see if I can get a question up for you to show you. But yeah, if it's not a prism, they will give you the formula. If it is a prism, I know on the formula sheet it says volume of a prism, and they give you that formula, but obviously that's like an umbrella term, isn't it? That's quite general. So you would then have to apply it to like a cylinder, maybe a cuboid or a cube or a triangular prism. You'd have to then apply it to a more specific shape yourself. So give me 1 second to find surface area one just so you can see. But yeah, also I've seen with Edexcel a lot of the time they'll give you like a hemisphere. They'll obviously give you the formula for a sphere, which is with radius in it, but in the actual question they give you the diameter. So you have to remember also all of these little details to keep halving certain things. So yeah, just be really careful because it's not just as simple as subbing it into the equation. When you say what about histograms, you mean formulas or you mean like just what about histograms generally? They won't give you a formula for histograms. You have to memorize that triangle, frequency at the top, frequency, density, class width at the bottom of the formula triangle is what, I don't know if that answers your question. Oh yeah, sure. Okay. So, okay, so you're doing the O level, aren't you? I need to check that one as well. I know that in the normal GCSE they give you the same formula sheet for all the papers. I don't know if that's the same for Cambridge. I doubt they would change it, right? It seems a bit too complicated to keep changing it. Here, let me just grab my surface area. I'm just going to look for here. I don't know if you can see like surface area of a sphere, and then they've given you in this kind of box the actual formula that you would need. Oh, that's it. Oh, there's not a whole lot of surface area actually. It's mostly volume, isn't it? So I'd say focus on volume if anything. I'm not a teacher, so I don't have the papers. So I cannot leak the papers for you. And also, you'll be fine on your own. Okay. Yeah, Malik, I think I would assume that you get the same formula sheet for all of them because that's what all of the others do. You get just the same formula sheet for all of them. But I can check. Okay, so I mean, when I look at it, it says formula sheet as in singular. So I'm assuming you get the same for both, I would assume. I mean, it's obviously best to ask your own teacher, they will know specifically that. But based on all of the others, I would assume that you do get the same formula sheet. That's my assumption. Okay, so let's see, we've got histograms. I don't know if have I done histograms yet? I don't think I've made one on histograms yet. I only started last year, so I haven't made all of them. We can have a look at some questions if you want. Algebraic proof, I do have a video on that. We can go through it now if you want, but I also do have a video on that, so you can find that on my channel anyway. So yeah, histograms is quite a big topic, I think. That's the thing, isn't it? So you're saying specifically interpreting histograms. So obviously they want you to work out median. Yeah, we can do a question on histograms. I'm just thinking because there's so many different parts to histogram. There's obviously drawing it in the first place, like plotting it. Then there's they might want you to work out a median or upper and lower quartile. Obviously that's an estimate. They might want you to work out the mean. And then as you said, then there's like the category of what I would class as interpreting histograms. So I'm assuming that's kind of more specifically what you mean, actually interpreting them. So it's probably a good one. See if it's Oh, hopefully that's not too blurry. You can read it. This is a 3-mark question. It was a calculator question as well, so you can use your calculators. So, okay, so they've actually drawn a histogram for us here. The histogram gives information about the height in meters of trees in a park, and then you can see that it's incomplete. Obviously, there's a bit missing. Okay, we can work out the median in a second as well. So this is what I would class as like an interpreting one, because it says 20% of the trees in the park have a height between 10 and 12.5 meters. So that's the bit that's missing, isn't it? The 20%, that's the bit that's missing. None of the trees in the park have a height greater than 25 meters. That just means that we've got the whole histogram apart from that one bar here that's missing, and you need to complete it. I don't know if that's also something that you wanted to kind of look into. Normally histograms, I kind of stick with this formula triangle. Frequencies at the top, I remember that because it's just one single letter, and then the other two go at the bottom because they're both 2 letters. That's how I kind of remember it. FD is obviously frequency density. You can see on the y-axis, class width, which is the width of each of these bars on the x. So if 20% is missing, we could work out the rest of it to be 80%, couldn't we? So I would probably work backwards to find the frequency of each of these bars and then add them up and go, well, that equals to 80%. And then actually this comes up in reverse percentages as well. Then you can find out the other 20%. So to find out frequency, if you cross that out, you see how you just multiply them together. So the first one, we just have to read it off really well, make sure the scale is, you read off the scale properly. That looks like 1.2, and then the width of this bar is 2.5. Obviously, as I said, this is a calculator one. So you would just multiply them together to find the frequency, and I would just do that for each of them. So that's 3. What was it? Trees. 3 trees. The next one is just 2 times 2.5. So that one would be 5. Then we've got, what's this? This looks like 2.8. 2.8 times 5. 14. And then the last one is between, this was 12.5, wasn't it? 12.5 to 25 is a width of 12.5. And then that's by 0.8, I would say. So 0.8 times 12.5 is 10. Obviously, all of these should come up as whole numbers, right? Because you can't have half of a tree. So then if I add that, 10 plus 14 plus 5 plus 3 is 32. So what we're saying is 32 trees, in this case, is equal to 80% of all the trees. We want to know how many trees are in this missing bit. So this is just reverse percentages. Now, because this is calculator, I could just type in reverse percentages, you always divide. And then because it's 80%, do you see how 0.8 is the same as 80%? Divided by 0.8. So there's 40 trees in total. So do you see how this bar here is obviously the other 8 trees, isn't it? So therefore, the 10 to 12.5 bar is 8 trees. And then you go, okay, well, I know the class width, I know the frequency. Now I want to find out the frequency density. So you kind of move that and go, right, well, that's frequency divided by class width. 8 divided by the class width is 2.5, isn't it? 8 divided by 2.5 gives you 3.2, and then you would just draw the bar there. So if I try and get my lines, and you just go to 3.2, obviously you have to draw this a bit better than I can. That's like an interpreting one. You can use either this formula, triangle. Sometimes if you don't have the frequency density, like they don't give you the scale, I would suggest counting the squares literally in each bar. There you go, now you've completed it. We'll do one on median and then we'll have a look at something else. I haven't drawn, have they? Okay, I'll get this one. Part A is to draw it, but we don't necessarily have to do that for the median, so I'll kind of skip that bit because you know how to do that anyway. Yeah, so Maura, I'm actually making a video on, like, I'm going to create my own predicted past paper, which we'll obviously upload before the exam anyway, so that'll be as like an actual video, but I can also go through it in a live if you like as well once I've like made the paper. But yeah, that's coming up. I do go through past papers, not predicted ones, but as in past papers. I do actually do lives on that, but they are the Edexcel ones, so that might not relate to those of you doing the Cambridge too much. So here, part B was to estimate the median. We've obviously got the frequency table. So it's only 2 marks really, but maybe there's a faster way to do it. The way that I think about it is obviously median is the middle, isn't it? So what's the context here? We've got the table shows information about the distances 570 students travelled. Okay, so it's students in this case. So we're looking for the middle student. So the first thing you're going to do is find 50% or half of whatever total they've given you. If it's an odd number, you can add 1 if you want, or just do it as it is. It doesn't really matter. So I would do 570, I would half that to find the middle student. So that's student number 285. So see how that's the 285th student. Then I have to say, well, what row would that student fall into? So it's kind of a bit like cumulative frequency. I'm going to add them up until I can find a row that includes number 285. So obviously the first row is only up to 120, so it wouldn't be the first row. Then if I add 90, that's 210. That's still not enough, is it? And then it's obviously going to be one of the middle rows somewhere in the middle. Then if I add 120 to that, what's that? That's 330. Do you see how the 285th student would, if you lined them up in order of distance, would be in this row here? Because that's between 210 and 330. Okay, so you have to first identify which row it is. Then you identify, well, how far into that row is my 285th student? So you see how the previous row finishes at 210. So this one effectively starts at that. So I would say, right, well, how far into it is it? So 285 minus the 210 that were the previous 2 rows gives me 75. So do you see how that's 75 students out of 120? You're trying to find like kind of like a proportion, like a fraction. They are 75 out of 120 into this row, into this range. And then you apply that fraction to your class width. So you see how the width of this one particularly is 30. Now, double check. This is also a calculator question, right? So I would do that times 30. That gives me 18.75. And that's now, in this case, in terms of miles. Now, that's not the answer because that's 18 miles technically would be here, wouldn't it? So you just need to then, the last thing you need to do is add the kind of lower limit, because it obviously starts at 50 miles, and then this person specifically is now another 18.75 miles into that. So if I add 50, you should get 68.75 or somewhere around there. I think they give you a possible range. They've said as long as you get somewhere between 66 and 72, they'll allow, 71, they'll allow it. But that's specifically what I got. So I don't know if that answers your question on median. This also applies for lower quartile and upper quartile. Obviously, instead of doing 50%, instead of doing half, for lower quartile, you would find 1/4 or 25%. And for the upper quartile, you'd find 3/4 or 75% to start with. But then once you've done this first bit, then the rest is the same kind of method. So hopefully that answers your question on histograms. Finding the equation of the circle. Okay, this also I think depends on if you're doing the normal GCSE, if you're doing IGCSE, or if you're doing something else, because I think the syllabus is slightly different on finding the equation of a circle. I know that the normal GCSE is quite a straightforward one, but I think IGCSE adds a bit more to it, so I don't know more specifically which one. Yeah, I only work currently for GCSEs. I only do GCSE at the moment, so I don't know if in the future I'll do A-level, but right now I'm only doing GCSE, so sorry about that. So, equation of a circle. Just having a look what questions I have. Yeah, I think I might have one on the circle one. A lot of it in normal GCSE is just asking for the tangent, actually, rather than the circle itself. Yeah, there's only one Edexcel question asking for the equation of the circle, but I don't know if you're doing IGCSE because I know that that's slightly different in terms of the syllabus is a bit extended. So it might be more so IGCSE that you're looking for. So yeah, I'll just wait and see what you've got to say about that. Is there anything else anyone wanted to look through? I know, oh, okay, Maura, I know you mentioned, oh no, Emily, sorry, I know you mentioned, where was it? Somewhere someone asked for algebraic proof. Yes, Emily. I can go through that now if you still want to have a look at it. Would you say the best way of improving in certain topics? Yeah, I think with maths, it's just about, obviously you have to have kind of got a vague understanding in the first place, right? But after that point, I would just suggest, especially at this point, because we're so close now, is doing as many past papers, as many practice questions. Ideally, at this point, I would suggest past paper questions, so questions that are specifically from well, if it's Edexcel, if it's AQA, OCR, if it's the IGCSE, whichever one, specifically those questions, because it's really helpful to get used to how they word their own questions, how they lay them out. Also marking your own questions, so once you've done it, have a look at the actual mark scheme, because I think it's quite helpful to also understand and be familiar with the mark scheme for your specific exam board, because also then sometimes you can look at a question and go, oh yeah, I remember because in the mark scheme it said I needed to write this, this and this, and so I know, you kind of roughly know what the question is looking for if you can get used to the mark scheme and as well as the papers. But yeah, I think at this point it's just exposing yourself to as many different questions as you can, but as I said, ideally of your own exam board. I don't think it's massively helpful at this point in time to start doing different exam boards. I would do your own exam board. Get really familiar with their questions, because a lot of it sometimes is kind of similar, and you can kind of start to pick up certain patterns. Like with Edexcel, I know they ask a very similar cumulative frequency question. The layout is quite similar, so you can almost guarantee that if you get used to that question, you can get that as if it comes up. You know exactly kind of what to put for part A, part B, part C. Yeah, anyone who has IGCSE P2 exam tomorrow, best of luck. I hope it goes well for you. If that's your paper 2, I'm assuming therefore you've already done paper 1, so hopefully that's it then. You don't have to do any more maths. I'm hoping that's what that means. But yeah, best of luck for anyone who's got it tomorrow. I know the normal GCSE starts in, well, at least the maths is in 2 weeks, isn't it? So you've got another 2 weeks. Okay, let me know if you have any other topics you want to go through, any other questions you want to have a look at. So yeah, I have 2 videos on ratio. Ratio is quite a random topic, I feel like. It comes up very differently every time, so that one's quite difficult. But I've got kind of a really straightforward video in terms of, first of all, how to share out a ratio, and then, which, is just kind of the first thing you need to know how to do. And then also how to figure out you know when they give you a ratio and then they give you the quantity of one side, you have to figure out the other side, or they give you the difference between the ratio and then you have to figure out, yeah. So I've got kind of those basic things. I haven't really got any that are kind of more complicated than that yet because they're so random, aren't they? But yeah, I've got 2 videos on ratios as kind of like a basis starting point. So you can always have a look at those. Okay, so yeah, if you want to list, are you, it depends what syllabus you're doing, I guess. If your exam's next month, I'm assuming it's not the normal GCSE. So what exams are you doing next month specifically? Is it like end of year exams? Are you year 10, year 11, or are you doing a different type of GCSE where the dates are different? Because if you're looking for a syllabus list, you can just Google whatever you're doing. Oh, it's mocks for year 10. Yeah, I was thinking that. End of year exam. It's hard because year 10 you won't have gone through the whole syllabus yet, will you? Because obviously there's still then year 11 to go. I'm surprised your teacher hasn't given you a list. I would suggest, I mean, what you could do is you could go and look up the syllabus. I don't know if you're doing Edexcel, whatever your exam board is. Look up the syllabus for that, and then obviously just the topics that you haven't, the ones that you know you haven't done yet, obviously just ignore those and then do the rest. But I don't know, it depends what your teacher is going to do for your mocks. Are they going to use a past paper where it's basically the whole of the syllabus, or are they going to kind of put together one where it's only including the topics you've done? It is a lot of the topics from year 7 to year 10 basically. Unfortunately, it's quite a lot. So yeah, a list, I don't know, it depends because obviously different schools and different classes go through the syllabus at different paces and in different orders. So I wouldn't know what you have and haven't done. That's the thing. I don't know if you have like a textbook. I don't know if you'd have a textbook for maths. If you do, you could use the contents page as a list. Or as I said, just Google, let's say if it was Edexcel, just type in Edexcel GCSE Maths Syllabus. It will come up and then you can kind of just ignore the pieces that you know that are going to be done in year 11, if that makes sense. Or if you know that they won't come up in your exam because your teacher has said. But you can also ask your teacher. I mean, that's probably a good place to start. Calculating the shaded side of a circle. I'm not sure what you mean by that. Do you mean like a segment? Or shaded side of a circle? Sounds quite niche, that. Quite specific. Is it like the segment? Is it a sector of a circle? What do you mean by the shaded side of a circle? Just need a bit more kind of context on that, and then I can see if I know what you're referring to. I'm just sending the link for the that's the ratio, one of the ratio videos for anyone who wants that. So quadratic formula. Okay, so quadratic formula is normally on the formula sheet, so you don't have to literally memorize it. At least, I mean, once you've used it a few times, you kind of end up memorizing it anyway. But that's on the formula sheet. Anyway, I think it's more so when to use it. So the quadratic formula is obviously to solve quadratics, right? X squared equations, to solve quadratic equations. Now, you can either just use it to solve any quadratic. Let's say if you have paper 2, paper 3, where it's a calculator one, if you don't want to factorize, because normally when you're solving quadratics, firstly, normally you would try and factorize. Normally, I feel like that's step 1. And then step 2, sometimes you can't factorize, sometimes it's literally impossible. Then you would, I was going to say complete the square, but quadratic formula, you would type it into your calculator and it would give you decimal answers. You could also complete the square if you really wanted to, but I don't really know people who tend to choose to do that unless they tell you to. Step 4 is technically, this is kind of on its own graphically. So these are the 4 different ways to solve a quadratic equation. And that's kind of in the order you'd probably go about it. Now, normally I would try to factorize. As I said, sometimes you can't, so then you would have to use the quadratic formula. Or sometimes if I'm in paper 2, paper 3, you know, where you've got a calculator, and part of my question is solving a quadratic, and it's like maybe got a number at the start, like 5x squared or something, and maybe the numbers are just really big and I don't want to have to try and factorize it. Sometimes I just automatically use the quadratic formula. Or if it's a question where sometimes they say, give your answer in a certain form or give your answer to 3 decimal places, then I know that I probably can't factorize it, so I immediately just use quadratic formula. But all you need to do, I mean, the actual quadratic formula itself is really easy. All you have to do is sub in the right numbers. So a quadratic is written like this. Obviously, it could be plus or minus, right? But you get the gist. And then the quadratic formula, obviously, it has to be an equation, doesn't it? So you have to make sure all of your quadratic is on one side, right? Make sure everything's on one side, there's nothing on the other side. And then this is the quadratic formula, which will be on your formula sheet. So, I mean, depending on your syllabus, but I know the main one, you don't need to memorize it. But do you see how the letters match up? You just basically sub them in with whatever numbers are. So the A goes here and here. The B is here. Be careful with this B here, because it says negative B. If it's already a negative, you make it positive. So you just apply a negative. So either it becomes negative or it becomes positive, depending if it's already a double negative. And then B squared here. What I would say about the B squared is if your B was a negative, right? If your B was a negative, sometimes if you type in a negative number squared in your calculator, it depends, but sometimes when you type in a negative number squared in your calculator, it calculates it wrong and it thinks that the answer is negative, which obviously if you know, when you square any number, square negative, square positive number, it becomes positive, doesn't it? So if you end up typing all of these numbers in and then your calculator says math error, if it says error, it's because something in the square root is wrong and it's most likely this B squared. So you can go back and double check that. Sometimes what I do if there's negatives in my quadratic is I just work out the negatives for myself, if that makes sense. Because I know how obviously negatives work. So just be careful. But apart from that, and then you'd obviously the first time just type in a plus, write down your answer, and then just use the back arrow on your calculator and then change it to a minus to get, because obviously quadratics you get 2 answers. So there's not really much to explain about quadratic formula. It's literally just as long as you sub in the numbers correctly and you know when to use it, that's kind of it. Now they can actually ask you to use quadratic formula in your paper 1, which you would think they wouldn't, but they actually can. And obviously what they will do is they won't make you square root anything. They'll just make you simplify all the numbers. You would just kind of try and simplify it. And sometimes, because obviously this square root ends up being a surd, sometimes they want you to simplify the surd, which is the topic of surds, isn't it? So I have seen that. This could come up in your non-calculated paper. Don't think that it won't. You would just obviously work it out manually. And yeah, as I said, you won't have to square root anything that's not a square number. Okay, so don't worry about that. I know we're not gone through a question, but I don't know if that kind of answers it at least. As long as you are substituting in your numbers correctly, you'd be all right with that. Simultaneous equations will always come up, whether it comes up as 2 linear ones, which is technically also in the foundation syllabus, or whether it comes up as 1 quadratic, 1 linear, which is obviously more towards the end of the higher tier paper, or whether it comes up graphically where you draw it. Any of those 3 scenarios could happen, but I would suggest that definitely one of those will happen. So I would definitely look at that. I do have videos on simultaneous equations as well. I have all the videos on those, so you can have a look at those videos as well if you want to, depending on which type of simultaneous equations you want to look at. Obviously, linear ones, there's two methods. There's elimination and substitution, so it just depends which of those you prefer. But when you do quadratic, you have to use the substitution method. So you might prefer to just learn substitution method for both. I personally like to use elimination for linear, and then I use substitution for quadratic. That's just me. When it's graphically solving simultaneous equations, you just look at where they cross, basically. Where the two lines or the curve or whatever it is, where they cross each other. So that's pretty straightforward. But I do have videos on all three of those scenarios, well, all four of those scenarios for the simultaneous equations. Yeah, so circle theorems, it's quite a hard one because obviously you have to memorize them. So once you've got them memorized, then it's kind of just depends on the question, doesn't it? Sometimes you can see it, sometimes you don't. So I think for circle theorems, it's probably one of those ones where it's the best to just try and do as many questions as possible, as many as you can find. Mostly specifically from your exam board if you can, because you might be able to pick up on maybe some similarities, maybe some patterns. But if there's not enough of those, you can also obviously try, I don't know, like Maths Genie, things like that. I do have videos on circle theorems as well. You can have a look at those. But circle theorems, there's normally maybe even 2 or 3 ways to solve them. So it's not necessarily that it's a right or wrong kind of thing. I mean, obviously if you get the right answer at the end, but it's not necessarily a right or wrong method, right? Sometimes you might have seen a different circle theorem than what I saw, but we both ended up with the same answer. So there are multiple ways to do circle theorem questions. So that's, I think, maybe a good thing. You can use different circle theorems. I think as long as you're really familiar with the circle theorems and how they might present themselves, then you kind of know what you're looking for. Like, for example, if the question doesn't have any tangents in it, then you know you're not using a tangent circle theorem, so you can eliminate those in your head already. Obviously, also circle theorem questions, you don't just use circle theorems, you also use any other angles, facts or information that you know, so straight lines. Could be a lot of triangles in there, isosceles triangles, things like that. So it's kind of just a bit of everything. Sometimes it's only even just one circle theorem and then the rest of the marks are like, well, this is like on a straight line, so take it away from 180. Sometimes it's not a lot of circle theorems. Okay, so the segment, yeah, I think it was a segment. It sounds like it was. And then yeah, I think that sounds like a segment to me. It's quite niche though. Are you doing Edexcel? Just so if I could look through the past paper questions I have and see if I can find that specific one. But if not, if it's just to work out the area of a segment, we can have a look at that generally. Proof, yeah, proof is quite nice. I also have a video on proof. Algebraic proof, I mean, some of it's fine and then some of it's a bit hit or miss, right? It depends on the question. But half of the time you probably could figure it out. An algebraic proof is quite good. You just have to know where to start, I would say. That's mostly the thing. So sometimes it's like worded, isn't it? They use words and then sometimes they give you kind of algebra to start with. A lot of it is just expanding brackets mostly, to be honest. So let me just grab a proof question and I can show you. Algebraic proof, okay. Yeah, some of it's a bit hit or miss, some of it is fine. This is probably quite a good example. Copy, let's do this one really quick. So, question 15, so you can see it's kind of beyond halfway. Oh, let's make it too big. Okay, hopefully you can still read that. So I normally split proof questions into 3 parts. So here they've got prove algebraically that the difference between the squares of any 2 consecutive odd numbers is always a multiple of 8. Now that's a lot to take in. So I split it into, first of all, what numbers are they, if it's worded like this is a worded one, right? That's how I would describe it. There's no kind of algebra to start with, it's just worded. I would first of all figure out what do I want to start with, what are the numbers, what type of numbers are they looking for? So do you see how here it's 2 consecutive odd numbers? That's what we're starting with, isn't it? So you need to know the algebraic definition of an even number, an odd number, consecutive numbers, even consecutive numbers, odd consecutive numbers. Once you've got that starting point, then you can kind of build it up. So for example, now you can technically use any letters, but they tend to use N for some reason, but you can use any letter. You can use X if you want. Odd numbers, algebraically, so you're not just going to pick random numbers, right? Because they have said algebraically, is 2n plus 1. That's one example. There's obviously loads of examples. But the reason is because 2n, any number multiplied by 2, any number doubled, is automatically an even number, isn't it, in every scenario. It doesn't matter what n represents. If I then times it by 2, it's even. So that's the definition of an even number, right? 2n. But if I then add 1 to an even number, do you see how then that's even, and then this becomes odd? Because obviously even numbers are always followed by an odd number, aren't they? So 2n plus 1, or you can use any letter you want. You could do 2n minus 1. You could do 2n plus 3. Like, you could do any kind of version. I normally just start with this. Now, so that's one of them. However, here they've said 2 consecutive odd numbers. So if I'm starting with this one, the next one would be 2n. The next odd number is 2n plus 3. Because if I did 2n plus 2, then that's the next even number, isn't it? Not the next odd number. So that's what I'm starting with. That's step 1. Then I work out, well, actually, what calculation have they asked me to do? Like, what do they want me to do with it? This is step 2. In this particular case, they've said they want to know the difference between the squares of these. So that means square both and then work out the difference. I might put it the other way around, actually, because the other one is... Yeah, an even number is just 2n, or you could do 4n, or, anything like that. But as long as it's a multiple of 2, it's an even number, isn't it? So yeah, an even number, the definition algebraically is just 2n. So if they ask for even numbers, you can use 2n. I might put it the other way around, actually, because that one's the bigger one, isn't it? But either way, let's just swap these. Plus 1. Anyway, so that's... And then at this point, I'm still not worried about what I want to prove. I'm literally not thinking about the proof until the end. So at this point, I'm going to actually obviously expand it and subtract it, simplify it, all of that stuff. So a lot of it, as I said, is just expanding brackets, really. So these are double brackets, aren't they? Don't just square the 2n and the 3. It is double brackets. So it's like 2n plus 3, 2n plus 3. It's like that, isn't it? So obviously you have to be happy with expanding brackets. Sometimes triple brackets come up as well, so be happy with triple brackets too. So you get 4n squared plus 6n plus another 6n plus 9 for the first one. You might not have used exactly the ones I used, as long as you've obviously got a definition of an odd number, it's fine. Minus, now the second one I'm going to put in brackets because I need to remember that I'm subtracting all of it, not just the first term. So I like to put the second one in brackets, even though I've expanded it. So that's 4n squared again, plus 2n plus 2, plus 2n plus 1. Obviously collect the like terms, simplify it, so that's plus 12n plus 9. Take away all of this, 4n squared plus 4n plus 1. So now I'm actually going to subtract it, right? Now I'm going to work out the difference. So obviously, do you see how the n squares, 4n squares would cancel? 12n minus 4n is 8n, and then 9 minus 1 is 8. So this would give you 2 marks already. This is a 3-mark question. This is already 2 marks. You might not even have proved anything yet. This is just 2 marks. Then the actual question says, now obviously my third thing is I'm going to focus on what am I proving? Now is the bit where I'm like, okay, what am I actually proving? It's always a multiple of 8. Now, if you can see my answer, hopefully that's kind of sparking some kind of logic. Normally, not necessarily always, but a lot of the time with proof at the end, the way that we prove things is by factorizing. Now, this one's a pretty simple factorizing one, because if you're trying to prove it's a multiple, then you factorize out that multiple. So in this case, we're proving it's a multiple of 8. Do you see how I can factorize out 8? So what this says, what this proves is that whatever is in my brackets, I don't really care what's in the bracket. If I then multiply anything by 8, it becomes a multiple of 8, doesn't it? So then I would put a little conclusion. I put therefore and just copy what they want you to prove. And it's always a multiple of 8 because n represents any number you could possibly think of. So I would probably put a little conclusion like that. That would be fine. That would be your last mark. Sometimes if they want you to prove that it's a positive answer, you have to factorize it. Normally it factorizes into double brackets that are the exact same brackets, so it's something squared, and you know the mathematical fact that anything squared becomes positive, so that's a different type of factorizing, right? But these are your kind of 3 steps, I guess. Yeah, this is like step 1, step 2, step 3. So you don't even normally have to worry about what you're proving until right at the end. But that's one example. Obviously, there are different types of proof questions, so I would probably go through a variety of them just to cover your bases. I have got a video on it, as I said, that has, you know, different varieties as well. I can try and find my link for that. Algebraic proof, where have I put it? Yeah. I'll put it in the chat. But you can have a look at more examples. That's algebraic proof. But yeah, it's more so just knowing what to start with, I think. That's most of the thing. Obviously, sometimes they give you algebra something to start with, in which case just start expanding it, basically, if they've done that. But even if you're not sure how to prove something, don't worry, just try and expand everything and then simplify it, and then see if at the end, either you'll figure out how to factorize it, or if you don't, then at least you've got 2 out of 3 marks. It's not necessarily that you have to know how to answer the question fully in order to answer it, you know, to start trying it. Okay. Oh, you're doing Cambridge, yeah. Okay. Maybe I can try and Google that one, because it seems quite niche, that's why I'm thinking that segment question. Segment question, let me see if it will come up. If not, I'll try and find an Edexcel similar one. No, I think I'll just have to find a different one, and hopefully it'll be something similar, is what I would suggest. Okay, I'll get something and hopefully it's similar, or hopefully at least answers, you know how to apply it to your specific question. This is an example. I don't know if you had a whole circle, but they've obviously just shown the circle sector here. It doesn't really matter, it would work the same way, right? You would just draw your radius lines if you need to. You can always draw lines onto your diagrams, right? If you need to add lines. Yeah, we can go over the equation of the tangent as well. So if you just want to find the segment generally, obviously they might draw the whole circle, they might just draw a sector, it's the same thing. It's effectively a cutout. So sometimes finding areas when it's in a really odd shape, sometimes it's more of a cutout situation because you don't have like a specific necessary formula for this. So what I would do is I'd work out the area of the whole segment, the whole sector, sorry, the whole thing. So this whole thing they've drawn here. In your case, if it was a whole circle, you'd obviously make it into a sector, right? Draw these 2 lines, work out the whole thing. Then do you see how it kind of creates this triangle? I'd then work out the triangle, and then the segment is just the difference. So you just take them away. So you just need to work out 2 areas. Now, obviously, you're going to need to know, I don't know if on your formula sheet with the Cambridge one, they have the area of a triangle, the formula, the trig one, not just the normal one, but the trig one. I'm assuming they would because they normally do on others, but I don't know. You'd obviously know better than I would. So area of a sector, this one I think I don't know with Cambridge, but with the normal GCSE, you do have to memorize this. Area of a sector is obviously the area of the whole circle, and then you just times it by the fraction of the circle that you have, which is in terms of this angle. So we've got 40 degrees out of a whole 360 degrees. So that's, well, I guess the formula itself is, I put theta, I don't know if you realize that, that's the angle basically. So in this case, for the area of the sector, I would do pi times, the radius is 8 in this case, isn't it? 8 squared times 40 over 360. I'm going to assume this is a calculator question. Sometimes they're not, but obviously they would use easier numbers, I guess. So I would do pi times 6, I just worked out the 64 myself, times by 40 over 360. Now, do you see how the actual number is loads of decimals? So because this isn't the final answer, I normally like to keep everything in terms of pi if I can, just to be really exact. So 64 over 9 pi. So that's the whole sector. So the kind of slice. That was a horrible picture, but yeah, the slice. Then I would work out the triangle, which is the area of the triangle trigonometric formula, which for normal GCSEs on the formula sheet, I don't know for you, I would hope it is. Anyway, it's half AB sine C. That's the one I'm referring to. So in this case, it's the angle and then the two sides between it, so the two radius. So that's a half times 8 times the other 8. Now you could call this A, B, and then this one here can be angle C, sine 40. So I would also, again, put that into my calculator, times sine of the angle 40. Now that one does give me kind of loads of decimals, so I'm going to leave the answer there, but 20.569-ish. And then, so that's like dot, dot, dot. Try not to round anything until the end. So then the segment, or the shaded bit, is just those two subtracted. So I'm going to get my calculation, put the 64 over 9 pi back in, and subtract my answer. So bring back the calculator. So this is still here. I'm just going to type over that 64 over 9 pi, and then I'm going to put minus answer, ANS, just because it copies all of those decimals. So then we've got 1.77. They've said to give it to 3 significant figures, which is 1.77. So now, because that's the answer, you can round it. I don't know if that answers your question. I know yours might have been slightly different, but I hope like the logic there at least. You just have to work out a sector, then a triangle, and then take them away. I'm hoping that kind of covers what you were wondering about. Okay, so next one was equation of a tangent. That one's really nice. Equation of a tangent is really, really nice because it's effectively just all of this kind of topics that you already know but put all together. So as long as you can kind of put them all together, it's fine. It's just basically perpendicular lines, really, is what that is. Let me just grab a question real quick. Yeah, it's just perpendicular lines. So I do quite like that one because it is quite repetitive. Let me just find it. There's one there, but this other one better. I'll go with a slightly more straightforward one first, just so you get the idea, and then you can apply it to maybe one that's a little bit harder. Hang on, where's it gone? Lost it. Oh, here. And this one comes up, I feel like they repeat this one a few times, at least Edexcel, I know they do, so it's a good one to know how to do. So this is an actual Edexcel past paper one. This is only 3 marks, because this one isn't like too difficult, but just to give you an idea, this one, I mean, it's kind of annoying because it has got surds, but it is paper 2, so it is calculator. So we've got L is the circle with equation x squared plus y squared equals 4. Now, normally, not always, but normally, the center of a circle, especially with Edexcel, I'm not saying, I think this is different for IGCSE, but possibly, but anyway, for normal GCSE, the center of the circle is normally 0, 0. If your equation is written like this, you see how it's just x squared plus y squared, there's no other, I mean, apart from the 4, ignoring the 4, but on the left-hand side, there's no other numbers. That means that the center, the circle center is 0, 0, so just bear that in mind. They've then given you point P, which is on the circle, so on the circumference, if you imagine it that way. Find the equation of the tangent to the circle. I don't know why I call it L, that's kind of confusing. At the point P. So a tangent is a straight line. All straight lines are y equals mx plus c, so that means I need to find out 2 things. The gradient, which is the m, isn't it? And then the plus c is the y-intercept. Where does it cross the y-axis? So you normally have to find the gradient first, unless you can physically see it in front of you, which we don't have a graph here, so we can't. So find the gradient first. Now, to find the gradient, you need two sets of coordinates, don't you? It's a change in y, change in x. If you think about the tangent, we have got point P, but we don't have any other coordinates. So you can't find the gradient of the tangent directly if you don't have two sets of coordinates, which we don't. So that's why I mentioned the other one, the 0, 0. So you can always sketch it if you feel like that helps. I mean, it depends if you're a visual person. Sometimes I like to sketch it, just depending on the question, if I want to visualize it. Because the circle center is 0, 0, I can obviously just draw a circle there. Hang on, where's my circle? Circle here. Wait. Let's say that that's my circle, right? And then what have we got? So that's 1.5, and then just roughly seeing what root 7 over 2 is, just so I can put it in the right quadrant, right? 1.3, yeah. So it's obviously in this positive, point P is in this positive quadrant, isn't it? That's 4. So 1.5 along, I don't know. Let's just roughly say that point P is like somewhere here, roughly. So then, do you see how my tangent, if I get my straight line again, my tangent is it going to let me draw? Why does it sometimes not let me draw a straight line? Oh, not again. Okay, I'm going to have to draw it without a straight line. Or maybe I can copy this one, hang on. I don't want to have to draw a not straight tangent. Okay. Okay, I'm just going to use this one. Again, this is all rough, right? This is not necessarily accurate, but... Oh, it's not letting me put it there. Oh, weird. Okay, that's my tangent, right? So, we only know point P. 3 over 2, root 7 over 2. We only know point P. Draw that 3 again. So, I can't find the gradient of the tangent immediately, but I do know this point here, obviously the center, 0, 0, and then, let's see if I can just, let me draw another line. Let's see, please. Oh yeah, okay, now it's working. That's then the radius, isn't it? Because obviously point P is on the circumference. Now, if you think about circle theorems, you don't need to write this, but this particular question is from a calculator paper. I'm just going through a specific topic, that's all. I'm not going through the whole paper, if that makes sense. So we know, I've not drawn it very accurately, but anyway, we know that in circle theorems, the radius and the tangent are always 90 degrees. They're always perpendicular. So you're just going to use that logic. You don't need to write it down. You just need to use that logic. So I could find the gradient of the radius, because I have got two sets of coordinates, whatever the center is. It might be 0, 0. I have seen an example where they did tell you that the center was a different set of coordinates. You just use that. Use those to find the gradient of the radius. So that's change in y over change in x. Obviously, in this case, the zeros don't really make any difference, but I'm just going to write it fully for you anyway. So just make sure you obviously get it the right way around. It's y at the top, isn't it? And then x at the bottom. So I would just type that into my calculator. Obviously, the zeros kind of make no difference, but just so you can technically understand where I've got that from. So that gives me overall root 7 over 3. Now, I would always leave your gradient in terms of a fraction if you can, because I want to then work out, obviously, the gradient of my tangent, which is a perpendicular line. So now if you think about the topic of perpendicular lines, how do we convert the gradient? Well, that's the negative reciprocal. You just have to remember these two words, negative reciprocal. So I need to do two things to this gradient. I need to change the symbol. Currently it's positive. As you can see, the gradient is going up. My tangent is going down, so it's going to be a negative gradient. If it was the other way around, if it was already negative, you'd obviously make it positive, right? You'd swap the symbol. And then the reciprocal means flip the fraction upside down, which is why I say leave it as a fraction if you can. So that would become 3 over root 7, which I know is an irrational surd, but technically that's what it is. Now you can obviously rationalize that. Like if I type that in my calculator, it will rationalize it for me. So you could write it rationalized if you like. That's kind of up to you. That's just to do asserts. So now I have the gradient of my tangent. The last thing is I need the y-intercept, which is the easiest thing. So I sub in my gradient, minus 3 root 7 over 7 x plus c. And then to find the plus c of any straight line, you just have to sub in one set of coordinates that are on the line, which is, in this case, p, isn't it? So now I can just sub p in. Again, make sure you put the y and the x the right way around, because that's quite easy to mess up. So root 7 for y equals my gradient over 7 multiplied by 3 over 2 plus c. And then do you see how now all I need to do is rearrange this and find or solve for c? So it's just the gradient that's kind of the complicated bit, I guess. The plus c is just the same as normal. This one's, I guess, complicated because they're all fractions, but... So that would be, what, 9 root 7 over 14. That doesn't simplify, does it? Minus 9 root 7 over 14. Obviously, this is calculated, so you can type it in. So I would add that across. So move it across. So root 7 over 2 plus 9 root 7 over 14. That apparently gives me 8 root 7 over 7. You see, so then all you need to do is go, therefore, my final answer, minus 3 root 7 over 7, x plus my c, which is actually positive, so I'll leave it as a plus, 8 root 7 over 7. Yeah, that's what they've got. You don't necessarily have to rationalize it. When I look at the mark scheme, you don't have to rationalize it if you don't want to. You could leave it kind of like that if you want. But it's those steps. So you just have to remember, if you're finding the equation of a tangent, you need to find the gradient of the radius first, do the negative reciprocal, so make it a perpendicular gradient, and then just find the plus c by subbing in the coordinates. It's always those 3 steps, basically. So that's quite nice. That's quite consistent, at least. So yeah, hopefully that... I mean, I know they're kind of complicated numbers, but hopefully that makes sense. Difficult probability questions. Yeah, a bit random probability, isn't it? Yeah, you've got a specific one from May 2018. Yeah, we can do that as well. Solving a cubic one, that's interesting. I'm guessing that that's not GCSE. I've never seen them solve a cubic inequality before. It's normally up to quadratics. Let's see. I'm guessing, do you just cube root both sides? Is that it? Yeah, I don't know. I do just cube root all of that. So, but then you still get the same exact answer when you get minus 1 is less than x, which is less than 0. So, yeah, that's interesting. Yeah, I think that's outside of the normal syllabus, that one. Yeah. What are you doing? I'm assuming you're not doing the UK syllabus. What syllabus are you doing, just so I can see? Because I've not seen that question in the UK syllabus before. A lot of people doing Cambridge, isn't it? That's interesting. I would assume you just have to cube root all the parts of it, right? So the cube root of this is my assumption because I've not seen a question like this before because I don't do Cambridge, right? But my assumption is you just cube root all the parts. So the cube root of minus 1 is minus 1. The cube root of x cubed is obviously x. And then the cube root of 0 is 0. So I don't know if that's just the solution, but that kind of seems like a trick question, doesn't it? That's my assumption for the answer. But yeah, I've not seen, because in my syllabus we've never had to do solving cubic inequalities. It's always like maybe linear or quadratic. So that's kind of interesting, but that would be my assumption. That would be my guess. Yeah, perfect. Okay. 2024 I don't have access to. I don't know if you have the question, but I don't think they've released it yet. If you're talking about Edexcel or AQA or something. So, yeah, if you have the question, then that'd be great, but I don't know if I have it. So hang on, let's look at the 2018 November. I'm just going to do that one really quick. Let me just grab that. I'm assuming you're talking about Edexcel, because that's the ones that I have here. 2018 November. What was it? Paper 1, question 14. Yeah, that looks right. Yeah, so x would have to be between those two numbers, -1 and 0. It would have to be something between that. Unless they'd be more specific, then you technically don't know which number it would be, I guess, do you? It's anything between those two. I don't know if you want, for that November paper, both parts or just one part. I know the second part's kind of the harder bit. This one. So this is 2018 November paper 1H for anyone. Yeah, I thought it'd be the second part, exactly. Okay. Actually, let me just grab the second part instead then. Yeah. It's a bit well, yeah, I can see why that would throw you off. But I think once you've seen it, you'll be alright. So, okay, there we go. Part B. This was question 14 for anyone who wants to know. Okay, so they've obviously given us 3 to the power of a is 1/9, 3 to the power of b is 9, and then root 3, 3 to the power of c is 1 and 1 over root 3. We need to work out the value of a plus b plus c. So, you know how obviously, hopefully you're happy with negative and fractional indices generally. So, for example, part A, you know how to do that. What they want you to do is, it's almost like they've given you the answer and they want you to work in reverse. So you need to not only be able to apply a fractional indice to find out an answer, but you also need to take an answer and then reverse it to write it back as a fractional indice or back as a negative indice, if that makes sense. So for example here, for A, we'll obviously do one at a time. We want to write it as 3 to the power of something instead of 1 over 9. So 3 to the power of A. I could first do 1 over 9. Instead of 9, I could write 3 squared, couldn't I? That's the first thing. And then I just have to remember, what is the 1 over? How do I represent that as a power, as an indice? That's a negative indice, isn't it? Do you remember when you do a negative indice, you make it the reciprocal or you flip it upside down? So that one is the same as writing 3 to the power of -2. So you just have to, you see how I've reversed it? You have to kind of use the same logic, but in reverse. So putting a negative power back in. So A would be -2. And then you do the same, so you keep going. So B, now this one's got 2 parts. So the 9 I could write again as 3 squared. And then root 3, think of your types of powers that we have. What is the power that represents a square root? So I'm going backwards again. Well, that's a half, isn't it? You know when you do to the power of a half, you would square root, wouldn't you? So you need to know that if you see a square root, you can put it back as the power of a half, for example. And then do you see how this is now index laws? So actually, let me write it differently than that. I'm not going to put brackets. It's effectively the same as writing this, isn't it? So with index laws, you see how I would add the powers? So that's like 2.5. So then B is 2.5. And then the third one is kind of a combination of the previous two anyway, so that's a bit repetitive. 1 over, we've just said that the square root of 3 can be written as 3 to the power of a half, and then we also said in part A that the 1 over is the reciprocal, which is negative power, isn't it? So do you see how that would be negative? 3 to the power of negative a half. So I'm just kind of reversing the logic that you would have practiced in a normal direction. We're just doing the opposite direction. So therefore, C is -0.5, and now all you need to do is add those together, basically, which you're going to be kind of annoyed at what the answer is after all of that. Add them together. -2 plus 2.5 is 0.5. Take away 0.5, 0. So after all that, the answer is 0, which I found kind of annoying. But yeah, that's how you would do that one. Just reverse kind of your knowledge of how negative and fractional indices work. And that was 2 marks. So hopefully that answers your question for that one. Yeah, it's kind of a tricky one, that one. Yeah, just see if you can kind of practice something mathematical in one direction. Just make sure you can also do it in the other direction. Okay, let's see. Oh, so the inequalities where you have to solve two of them. Yeah, so you have two. Sometimes one's linear, one's quadratic. Sometimes they're both quadratic, and then you have to solve at the end for both. Yeah, we can do that. Again, that's quite a nice one. It's just knowing what to do. Once you know what to do, then it's fine. So I think I've got a question specifically on that. Inequalities. Hold on, let me find it. Inequalities. Multiple inequalities. Here we go. Yeah, this can be a 5-mark question. And let me paste it. It'd be great if it did. I don't have to print screen, it's not letting me. There we go, right. So something like this. Sorry, it's a bit blurry, but. So, find algebraically the set of values of x for which you've got both inequalities. These are both quadratic, so normally, well, the first one you don't have to factorize actually if you don't want to. I kind of naturally did, but you don't have to. Obviously, normally quadratics, you want to try and factorize them, right? So what I would do is I would ignore the inequalities initially and just think of it as, like, you can write equals if you find that helpful. So either this one you can add 49 and then square root, but I just saw that as difference of two squares. So whichever version of that you want. Obviously make sure you do get two answers because it is a quadratic, not just one. So here x would be -7 or +7. That one's pretty straightforward. The second one, I think this was on, oh, for some reason I haven't written it down. This one I would probably put into the quadratic formula. You can obviously factorize it, but I would probably put it into the quadratic formula just because the numbers are really big and I just wouldn't be bothered to try and factorize it basically. So I would probably solve that with the quadratic formula. That's just my choice. You don't have to factorize. You can always use the quadratic formula if you prefer that. So minus b, that would become +31 because it's already negative. Plus or minus square root of b squared. Now, I know it's -31, but I'm just going to write 31 because when you square it, it should become positive. I haven't written it down. I don't know why, but I think it was. There was one that wasn't, but that was a linear and a quadratic one. There was another one. I've got like 2 examples. That was non-calculator. I think this was a calculator one. Yeah, is my assumption, because looking at the mark scheme, they've allowed you to use this. So -4 times a times c. Obviously, I would just type all of this in. Just be careful. If you do get an error when you do quadratic formula, it's because something in your square root has gone negative, and obviously it can't be a negative. So just double check that. So I would just, let me type that in really quick into my one. 31 squared, 4 times 72 times 5 over 10. So one of my answers for the plus, obviously I'll type in plus first, is 8. Then I go back, change it to a negative, and I get, yeah, so you could have factorized it. I just, to be honest, couldn't be bothered because the numbers were too big. So I've got my answers, right? This is most of the marks. That would give you 3 marks. If you got this far, that would give you 3 marks, I think. 1 there, 1, 2. Oh no, 2 marks, sorry. That would give you 2 marks out of 5. Now, obviously, we want to put the inequalities back in. Now, you might just want to memorize it, okay? It depends on which way the symbol faces, right? If it faces towards the quadratic, it means, because with quadratic inequalities, you've got two formats of answers. There's only two possible formatting of the answers that you can get. In this case, it's facing towards the quadratic. That means you're going to get two separate inequalities. So just remember, x has to be smaller, less than the smallest number. So in that case, that would be -7. And x has to be bigger, greater than the biggest number. Now, it's actually the same for the second one because they're both facing the quadratic, aren't they? So x has to be smaller than the -9/5, because that's the smallest number, isn't it? And bigger than the biggest, which is 8. Now, just so you know, if it was facing the 0, it would be a range. So like, just for example, let's say you had the exact same one as the first one, but it was facing 0, your answer would be between the two. So if it faces 0, it's a range, it's between the two numbers. If it faces the quadratic, it's two separate answers, but remember that x is less than the smaller number and greater than the bigger number. Now that's 4 marks. Obviously, as you said, you want to then combine it, don't we? We want to have an answer, a set of values for x that works for both, because currently it's still separate. Now, you might be able to just figure it out by looking at that, but if you don't, you can always draw a number line. So I just roughly, it doesn't have to be scale. -7 is obviously the smallest, then you've got -9/5, then you've got 7, and then you've got 8. So for this first one, you've got something that looks a bit like this, isn't it? If I were to draw it. And then for the second one, it's like this, and then like this. Let me just extend that one. And then I would just see where they overlap. And so what I mean by that is, if I get my highlighter, you see how they both overlap the -7, but then they both overlap the 8. So my final answer would be x is less than -7, so the smallest of both of them, and x is greater than the biggest of both of them. Obviously, if it was a range answer, you'd look at where they both overlap in a range. So that'd be your 5th mark. So solve them separately first, then put the inequalities back in, then figure out where they overlap, is basically the logic. I don't know if you wanted to see a different one or if that kind of if that answers your question. Yeah, this will be uploaded. I think when it finishes, it just uploads, or if not, by tomorrow, it will have processed properly. I'm not sure, but it will upload itself. So in terms of more lives, I'm going to have another Q&A like this one where you can just ask anything. The next one will be Sunday at 4:30. But after this, so at 7 o'clock, this is currently what, 6:30? So we'll finish this one soon. At 7, I'm going to be going through an Edexcel higher tier paper 1. So that's not like a Q&A, that's just like I'm going through the paper. If you have questions about that specific paper, we can do the questions there. But yeah, at 7 o'clock today, I'll be going through that paper. Obviously, that doesn't necessarily help you guys who are doing Cambridge, but anyone who's doing Edexcel higher, you can obviously jump onto that. But the next Q&A one will be on Sunday at 4:30. So just so you know. Yeah, hopefully that answers your question on that. Hang on, and check if I've missed anything. Factorization, sketching graphs. I also do have videos on some of these topics, so you can also, like, if we don't have time in the live, you can also have a look at those videos. I've got loads of videos on factorizing, if that is helpful as well. We also, I mean, technically have, well, this is difference 2 squares here. I didn't really factorize the other one because I didn't really want to. It was too big of a number. Question 22 from November 2018 paper as well. Hang on, I think I still have it up. Oh yeah, probability. Actually, someone asked about probability questions, right? So this should work for both of you. Uh, 6 marks. Yeah, this one is a huge question. Okay, so this is also the November 2018 paper 1. So this is non-calculator, this one. Okay, Right, so here we've got, there are only green pens and blue pens in a box. There are 3 more blue pens than green pens in the box. And then they just happen to say there are more than 12 pens in the box. Actually, I think I've gone through this question in one of my videos. I think I just did a video on hardest probability, and this is one of the questions I'm pretty sure I went through. So Simon is going to take at random 2 pens from the box. This bit here, when they take 2 or 3 of something, it makes me think probability tree. So I'm probably, you don't have to, but I'm going to draw a tree. That's how I like to do it. As I said, I'm quite a visual kind of learner in that sense. The probability Simon will take 2 pens of the same colour is this. So this is kind of like the answer to the probability tree, isn't it? This bit here, this is like the answer, saying this is blue and blue or green and green. So work out the number of green pens. Okay, that's a lot of information. I'm just going to set up a tree. Now, obviously, I don't know any numbers, so we're going to have to use algebra, right? Now, I don't want to use... So, for example, you might go, oh, I'll put G for green and B for blue. Those are 2 letters. I don't want 2 letters because you see how the only information I really have to create an equation is this. That's only one equation. So I can only have 1 letter. You can't have 2 letters in one equation, right? You can't solve that. So that's telling me, no, I'm not going to use 2 letters. I'm going to use 1. So that's why I'm looking at this sentence here. There are 3 more blue pens than green. So I normally label X as the smallest one. I think in this case, it's the green is smallest number of pens, isn't it? Because then, do you see how blue is 3 more than that? So I could write X plus 3 for blue. So now they're both, in terms of X, they're both the same letter. So now my tree. So I can either, for his first pen, obviously it's either green or blue. In terms of probability though, the probability of picking green would be green, which is X, over the total. So the total, actually I'll write that over here. The total pens in terms of X is the green plus the blue, which is obviously 2x plus 3, isn't it? So do you see how my denominator would be 2x plus 3? That's out of all of the pens. And then for blue, it's obviously then x plus 3 at the top, 2x plus 3 at the bottom. That's the first one. So that's fairly straightforward. Now the second pen is then kind of where it's a bit more complicated. So second pen. Because it says Simon is going to take at random 2 pens from the box, I'm assuming that he's not replacing them. He's just taking 1 and then taking another, or he's literally just picking up 2 at the same time. Oh, sorry. So he's not actually replacing them. You know how sometimes they say they take 1, they put it back and so on. No, I don't think he's replacing it. So when I then go to pick, let's say we're following this branch here, we've already picked 1 green. So in terms of picking another green, there'd be 1 less, wouldn't there? But also in terms of picking another pen, there's 1 less in the box. So you see how now it's 2x plus 2 at the bottom. So not only has the numerator changed, the denominator as well. So just be careful of that. So also here, picking blue, well, he hasn't picked a blue yet in the case of this branch. So it's still x plus 3, but the denominator is 2x plus 2. And then here we've picked a blue, so the green would still be x, but obviously again over that reduced denominator. And then picking a blue after already picking a blue would be x plus 2. That's 1 less, isn't it? Again over 2x plus 2. So that's my tree. Now I'm going to come back to the sentence. So get my highlighter ready. It says the probability that Simon will pick 2 pens of the same colour. So I need to highlight those options. Do you see how that is? Either he could do green and green or blue and blue. Those are my 2 options. So I'm basically using this to create an equation, basically. So how do I normally calculate stuff from a tree? Well, between the branches you have to multiply, don't you? So for example, if I wanted to work out the probability of both green, I would do x over 2x plus 3. This is why this is 6 marks and at the end of the paper, multiplied by the other one, x minus 1 over 2x plus 2. That's green, isn't it? That's blue. Try again. That's the green probability of getting both greens. Now, same thing for the blue. If I want the probability of getting both blue, I would multiply them. So that'd be x plus 3 over 2x plus 3 multiplied by x plus 2 over 2x plus 2. And then, so that's blue. And then you know when you've got a tree and you have multiple options, multiple possibilities. Here it's either he's going to get both green or both blue. You then add them, don't you? So, in order to create my equation, I'm going to rub this out, this tree, hopefully. I mean, if you need to see it, you can obviously, go backwards. I'm just going to rub this out so we have the space. That's not going to work, is it? Let me try a bigger rubber. There we go. I need to set up an equation, effectively, isn't it? So my equation is the green which is all of this, 2x plus 2, and then add the blue. As I said, you might have been able to do this without the tree, but I personally could not. I had to draw the tree so I could visualize it. 2x plus 2. And then that is what is equal. That is what is equal to 27 over 55. So, do you see how, I know it's complicated, but effectively at this point you can forget about the probability, and now we're just solving equations. Now we're just going to try and multiply this, add it, rearrange it, whatever. We're going to try and solve it. I think it's going to be a quadratic, but now it's just a load of rearranging. So multiplying, obviously just multiply straight across, x squared minus x. Would I expect, why have I put a bracket there? Oh, that was massive, wasn't it? Try again. There we go. Yeah, I guess we're going to expand the denominators either way, aren't we? So let's expand that as well. So that's 4x, you just have to be really careful you don't get anything wrong here because there's so much going on. 4x squared plus 4x plus 6, so that's plus 10. X plus 6, and then obviously they have the same denominator, so that's easier, isn't it? X squared plus 2x plus 3x, which is 5x plus 6. Same denominator. If I've done anything wrong, please shout in the comments. Is that, and then obviously we don't want fractions, so I would, well, technically those you could just add together, couldn't you, actually? It doesn't really matter which order you do this in. You could cross multiply straight away if you wanted, but we could just add those, so that's a numerator of 2x squared plus 4x plus 6 over the same 4x squared plus 10x plus 6. Now, you could cross multiply now. What I'm thinking is, you see how that first fraction, all of the 6 terms are multiples of 2? So actually, I would probably just I try and simplify everything that I can. You can divide everything in that fraction by 2. So I'm just going to simplify that, just so that when I multiply by 55 and 27, they're not massively huge numbers. Plus 2x, especially because this is non-calculator, isn't it? So yeah, that might be helpful. You can only do that if all of the terms are divisible by the same number. The person wondering about linear sequences, I do have a video on that as well, so if we don't have time now, you can also have a look at my channel. There are, I think I called it linear nth term. You can have a look at that on my channel as well. 2x squared plus 5x plus 3. Now I would probably cross multiply because I don't want to have, I don't want to have fractions. I can't solve anything with fractions, right? I don't think 27 over 55 simplifies, which is annoying. Yeah, it doesn't. So we're going to have to cross multiply, as in multiply by the denominators so that they cancel out. So all of that's multiplied by 55, which is, as I said, mildly annoying, but that's fine. 55x squared plus 110x, and then 3 times 55 is 165. I just added it, basically. And then 2 times 27 is 54. Oh, what was that? 5 times 27, so times by 10, which is 270, divided by 2, which is 135, I think. Hopefully. And then 3 times 27 is 81, because that's 3 to the power 4, or 9 squared. Quadratic simultaneous equation, I also have a video on solving that if you want to have a look at that, because I'm going to have to finish this live probably after this question, because I have another one at 7. So yeah, if you want quadratic simultaneous equations, I do have videos on that. Just look through the higher tier playlist, or search it on my channel, it's on there. So we've obviously ended up with a quadratic overall. I like to move all of the terms to the side where x squared will remain positive. So I'm going to move all of these to the left, because you see how if I subtract 54, it would still be 1x squared, wouldn't it? So that would be x squared, take away 135, which is minus, no, that's wrong, minus 25x, I'm pretty sure. This is where you've got to be really careful, isn't it? 165 minus 81 would be, so minus 80 is 100, is 85, 84? Hopefully I've got this right, otherwise it'd be kind of annoying at the end if it's all wrong. Now we've got a quadratic, now we can solve this, now it's non-calculator, so I'd probably factorize it. And given that the context was pens in a box, you know that you're going to get whole numbers, right? So we can factorize. We're multiplying to make a positive, adding to make a negative, so they're both negative. So factors of 84 that add up to make 25, I think was just 4 and 21. I think it wasn't that complicated. So then you solve it, we've got 4 or 21. Now obviously we've got two answers, right? You obviously only want to have one answer. So if I come back, do you remember, let's try and actually remember what x was in the first place. X, I said, was green. That's what I labelled it as. You might have labelled it differently. So if x is green, this is the only other bit of information we haven't used yet, is this. They happen to say there are more than 12 pens in the box. So then you can use that to figure out which of the numbers was correct. So we said x is either 4 or 21. If it's 4, if I added it, so we said the total number of pens is 2x plus 3, isn't it? Do you see how 2 times 4 is 8 plus 3 is 11? That wouldn't be enough, would it? So it has to be 21. Now, what was the actual question? Oh yeah, they were asking for green pens, so you just leave 21 as your answer. Okay, so 21 was the answer to that one. But yeah, it's a long question, that. It's just knowing how to set up that initial equation. 21 is your answer. Okay, so express something in terms of the other. I was just making that whatever letter that is as the subject. So just make whatever, which depends what letter it is, make that the subject and put everything else that is not that letter on the other side of the equation, basically. That's all they mean by that. Well, it depends what question you had. I don't know if you have a specific question that you were thinking of. Interquartile range is just the upper quartile minus the lower quartile. So you just have to work out both of those. Okay, I'm going to send links for certain things that people have asked for, because we're going to have to finish the live soon. But I will be going through a paper 1 Edexcel literally in 10 minutes. So if you want to have a look at that paper, we can do that. But obviously it's just that paper, it's not random questions. So the next one, the next Q&A drop-in session will be on Sunday at 4:30. So I know someone asked for linear nth term. So I'm just going to paste that link and write down what it's for actually, so you know. Linear nth term. I can also link these obviously in the description as well anyway, and in the comments. The other one was quadratic simultaneous equations, wasn't it? Also, again, you know, if you come on Sunday, we can also have a look at these when we have some time again. Where's my quadratic? Yeah, quadratic simultaneous. Here we go. Quadratic simultaneous. Oh. There's a link for that one. Yeah, so the paper will be going through just now in like 10 minutes. Is a higher tier paper. It's Edexcel, just the normal GCSE. It's not IGCSE or anything. It's just normal GCSE, higher tier Edexcel, and it will be the November-June one, 2020, because obviously in 2020 they didn't have, like, they wrote the June paper, but then obviously you didn't do it because it was COVID, so they moved it to November. So it might be called November, it might be called June, I don't know. But that's the one we'll be going through. It'll be paper one, because obviously for the normal GCSE students, the paper one is the first paper coming up in 2 weeks' time. So that's why for the next few weeks we'll be doing paper ones. After that paper, you know, in actual, on the 15th of May, we'll then be moving on to paper 2 and paper 3, which is calculator. Okay, so I'm going to have to leave the live here for today. Thanks for coming, guys. If you found it helpful, obviously let me know in the comments. Like and subscribe, and on Sunday will be the next drop-in session. If you have any other questions, we can do it then. Okay.